The problem statement for HR analytics case study is to predict the employee attrition risk. That is, to predict the employees who will leave the company. We followed CRISP TM framework to solve this problem. The first step of CRISP TM framework is business understanding. In this case, to know who will leave the company and the factors that are responsible for the employee to leave the company so that the company could focus on these factors and reduce the employees' attrition. The next step is data understanding. In data understanding, we perform data cleaning. So in this case, we had missing values, but the ratio of missing values to the actual values is very less. So we did not consider missing values for further analysis. We did not have any invalid data in this case. So we moved on to the next step, that is exploratory data analysis. We performed outlier analysis, checking for outliers and replacing them with their preceding values or succeeding values. And we also performed scaling to normalize all the values in a particular variable. And we perform univariate analysis, that is analyzing one variable at a time, and bivariate analysis, that is analyzing two variables at a time. Then we proceeded to the next step, that is model building. We proceeded with the backward stepwise selection, wherein we'll start with all the variables and we will step by step reduce one variable at a time which are insignificant. We will find out the insignificant variables and remove them by using p-value and VIF, variance inflation factor. Variance inflation factor tells us about the multicollinearity. We'll proceed this way until we are left out with all significant variables. And then after we get the final model, we'll proceed to the further step, that is model evaluation. We perform model evaluation so by selecting sensitivity, specificity and accuracy, by selecting the cutoff so that the sensitivity, specificity and accuracy will be optimal. And then we proceeded to, after selecting the optimal cutoff value, we found out, we evaluated the model further by using lift and gain charts and KS statistic. Going to the next question, that is, what is the output of a logistic regression model? The output of logistic regression model is probabilities. How do you convert probability to a class label? And how do you choose the cutoff probability? We chose the cutoff probability so that the sensitivity, specificity and the accuracy are optimal. Are there any other hyperparameters in logistic regression model? We also consider p-value and VIF in backward stepwise selection. How did you choose the relevant features? How do you convert categorical variables to numeric? We convert categorical variables to numeric using dummy variables. For example, if you have male and female as a variable in the variable, so you can convert them to ones and zeros. What is stepwise feature selection? So coming to feature selection, we'll select the features or variables based on their uh, significance. In this case, we have three stepwise features, that is forward stepwise, backward stepwise and uh, so in We selected backward stepwise in this case. Can you explain the model building process? When do you look for significance and when VIF? We basically uh, consider values with VIF greater than VIF less than 2. So if VIF is greater than 2, we'll uh, reject those variables for further analysis. We'll eliminate those variables for further analysis. If you have a variable which is highly significant and has high VIF, should you remove it? Why? Yes, we should remove it because VIF basically describes uh, multicollinearity. If we have the variable with high VIF, it means that it is collinear with other variable, so which will give us wrong predictions. So we have to remove it. How do you evaluate the model? We evaluate a logistic regression model based on sensitivity, specificity, and accuracy, and we use lift and gain charts and K statistic. What is accuracy? Accuracy is nothing but the ratio of number of yeses predicted correctly. I mean number of true variables that are predicted correctly. Actual true variables that are predicted correctly. It is a percentage. What is discriminatory power? What does discriminatory power measure? What does discriminatory power measure which accuracy doesn't? So discriminatory power is nothing but the distinguishment between the values that are predicted correctly and wrongly. So discriminatory power uh, is different from accuracy because discriminatory power predicts the values with respect to random model, whereas accuracy doesn't do it. Can you list some metrics which measure the discriminatory power? I used statistics and lift and gain charts uh, for measuring discriminatory power. What are deciles? Deciles are nothing but we will split the data in terms of percentages, that is 10%. I mean, we'll split the first 10% of the data as first decile, second 10% as second decile, like that. What is K statistic and what does it measure? K statistic is nothing but the difference of cumulative probability of number of yeses predicted as yeses minus number of no's predicted as no's. What is ROC curve? What does the area under ROC curve indicate? So the area under ROC curve should be high for a good model. Can you explain the results of the model in terms of business benefit? Which variables are indicators or predictors of attrition? How well can you predict attrition? In our case, we have predicted 75% of the correct values. That is, we got accuracy as 75% when we chose 0.181 as the optimal cutoff variable. What is the risk of having high false positive rate? So false positive rate means that of the variables that are, I mean, predicted uh, correctly, we false positive rate corresponds to specificity. So in our case, since we are predicting the attrition risk levels, I mean the number of employees that are leaving the company. So in this case, uh, specificity describes the number of people who are leaving the company that are predicted correctly. So we should consider on high false negative rate, which is nothing but the number of employees who are predicted as not leaving the company, but they are leaving the company.